And I guess once we hit like 9, we'll give everyone a few minutes to kind of join in and then get going. Oh, are we live on the YouTubes now too?
In 5 minutes, I think.
I don't know if I think we went live. Yeah, I think we're live. We are live. We're live. We're just waiting around. So I'll let people know. We're just waiting. We're waiting till we start around like 9, letting everyone come in. When you come in, if you want, you can say hello, introduce yourself if you want to. If not, you can just hang out and listen to the questions and see what some of the answers and stuff are.
Me too.
And then let me see. Let me get up. So welcome in if you're watching on like YouTube or something. We're just gonna we're hanging out for a few minutes, and after that we'll get started. It should be about, I don't know, it depends on how many questions we get from people that join. I think we've got about like 8 to 10 questions that we saw at KubeCon that were interesting. I'm gonna ask them and then see what Tomas says. Tomas didn't actually go to the one in the US this time. He went to EU. And are you gonna go to Paris? Expecting to go to Paris? Should be easy trip for you.
We.
Yeah, yes. Yeah. I was like, oh, you're taking your partner. It's like we're taking a trip. I mean, Amsterdam was a lot of fun.
I think everyone's going to do that, right? It's like Paris. I mean, like,
yeah, I think
you go there early, like 2 days or 3 in the same hotel. You like take your partner, and it's like, oh yeah, romantic Paris, whatever. And then it's like conference.
Are you gonna go to Disney, EU Disney down there? That's one of them.
Never been to Disneyland in my life.
Oh wow. I've been to Disney World because that's like a US thing, and I lived on the East Coast, so like you could just make it down to Florida within a decent amount of time. But I've never been to Disneyland in California or Disney in any other place. Where I grew up, though, like the place that we had was called Busch Gardens, and Busch Gardens was a like kind of German themed almost, right? Like so, it's like you would go there, you're like, oh, what is this? It's like it has like Oktoberfest and different things like that, and then a bunch of roller coasters. But like that's Williamsburg, Virginia, which is.
Okay, never mind. That sounds German.
Yeah, it has Colonial Williamsburg is like where that area is, and then yeah, Busch Busch Busch, like so like
yeah,
beer,
that's
right?
the
Like
German
Busch
one.
Gardens. Yeah, so that's where we would go when I grew up. But when I went to Paris in 2014 for an OpenStack Summit, and one of the guys that came with us, he was very excited about going to Disney, so he went down to Disney and. It's like right outside of Paris, right? Like I think I watched a documentary kind of talking about it, like they've rebranded because it's like they had to do things to where like people in France actually liked it. Otherwise, they're like, we hate this thing. We hate it so
that
much.
Makes sense.
Yeah,
I mean, this is one with like McDonald's and France. If you take a look, like in France, you've got McDo, and it's basically completely different than what you've seen in like Germany or other countries, and it's super high quality. And they don't even have throwaway things anymore. It's like nothing made out of cardboard or paper. It's just everything reusable plastic. So it like really depends on the culture and where you are. And I think in France, it's like very special.
I think
that seems
we can
better.
start.
Okay. All right, so we'll go ahead and get started then. Welcome everyone. This is interactive, so if you have questions or comments or anything like that, once we get started, just go ahead and post it in the chat. And if you want to introduce yourself, you can. If not, just sit back, relax, and we'll walk through like some of the stuff that we got asked at KubeCon. This is KubeCon Chicago. All right, so welcome to, I think it's our second office hours is what I'm hearing. So I didn't go to the first one. I'm here for the second one. So hopefully we'll have some more of these coming up next year too. All right, and let's get started. So your hosts. So I'm Mike Peterson, tech marketing at Loft Labs, and I write blogs, do some of our videos, and do some of our 101 stuff and things like that. And then we got Tomas, if you want to introduce yourself, our software dev at Loft Labs.
I'm one of the software engineers working at Loft, working on vCluster on a commercial offering, as well as things supporting it and driving the things that go into the future, and also refactoring and fixing bugs and the standard stuff that software devs do.
One of our resident experts. I can say that, right? Like if I have questions, I'll go to Tomas.
Whenever I hear expert, I have to think of enterprise, and then it's like, I don't want to be an expert.
I like expert because then there's like way more expectations.
Yes, yes. It's like the moment you hear expert, you've got like the bars
Yeah.
here. Then you're like, I'm here. And then it's like, enterprise, what do you mean? You don't have this teeny tiny little bit of extra knowledge that we require.
One of our
Yes.
intermediate
Thank
people
you very
with
much.
vCluster. All right, so here's our agenda today. So intro might be a little bit shorter than 5 minutes. We're just kind of we have a QA. Let me bring everything up. Oh, we've got someone from Edinburgh, UK. How's it going? Thanks for joining. All right. Oh, let me go back. All right. So our intro, 5 minutes. We'll have some questions that we saw from KubeCon. Then we'll have Q&A. Although, like I said, if you have Q&A, oh, Hannah's saying the chat's disabled in the regular chat. I guess we can use it. We can either use a QA
The
section
chat is
or
disabled.
chat disabled. Okay. Yeah. Well, I don't know if whatever. I'll see if Ashish can do that as I keep going. All right. So intro, 5 minutes, questions from KubeCon, QA, and then a quick little outro kind of showing like how you can find information about vCluster, how to contribute, and how to actually get questions answered outside of the office hours. But like I said, so Mike and Tomas, and then we've got Ashish here helping us out. Thank you so much, Ashish, for putting this together. That's who you saw like posting messages and everything. And if you find this useful, let us know, and we'll try to do these more in the future. So let's go to our very first question, right? First thing, is vCluster mature now?
I mean,
the weirdest. I put an M for mature, right? So it's rated
yes.
mature, but let's see what Tomas has to say.
I mean that's a great question. But like going back, what does mature really mean? Like, is
Yeah.
somebody who's 21 mature enough to drink alcohol? Well, in the US they are, but in Germany you're mature enough when you're 16. So it's more of a question of what your expectations are. When we like look at vCluster, it's exactly what like we want it to be. It's a fully certified or fully conformant Kubernetes distribution when it comes to your APIs, to working with it. So in that sense, it's mature. It's already battle tested over the last couple of years, and even with customers now, with bigger customers, they're running it in production as their services or things powering their services that they are giving away to other customers. So from a maturity standpoint, or let's say from a reliability standpoint, it has been shown that it is there. But at the end of the day, if you say that a project that's 2 years old isn't mature enough, then that's fine. But I mean, in the cloud native space, anything that's older than a year is probably already outdated. So in that sense, with a couple of years under the belt, it's probably mature enough for what you're dealing with.
So say it was a CNCF project, what stage would you put it at? There you go. Because people are using KubeVirt in production and stuff like that, right? But like I remember when people were like, is this mature? It's like, well, it's not even like 1.0 yet, but like you're using it. So I guess it's mature enough for the feature set that you need.
I mean, like the versioning thing, it's a thing on its own, right? If it's 1.0
Yeah,
or if it's not, it's I mean, even Kubernetes, if you look at it doesn't really conform to Semver, and it only got the version 1 to basically be like, yes, and now Kubernetes is stable. But if you look at versions, Kubernetes is like still doing major version changes between 1.25 and 1.28 or 120 to 128. Like entire APIs are ripped out. You need to replace ingress deployments, whatever. So like, is that really mature? Well, yes, it has a 1 in front of it. So I mean, it's not really true, but it is mature, but it's not really true that it's easy to go with. But yeah, I would also say that vCluster itself is not going to have major breaking changes, or at least we're not anticipating those major changes to suddenly change the entire CLI, for example. So it's not going to break in that sense.
All right, cool. So I'll ask a question too. I won't use names unless you want me to, just because this is getting recorded. But is it production ready for critical business applications? So I would say
It's a
yes.
great question.
Some customers are using it, but yeah, Thomas, go ahead.
Yes, no, that's a really great question. So from an architecture perspective, it basically just synchronizes things, right? So it's a smart way of holding your data and translating whatever's necessary. So at the end of the day, even if the vCluster API server would die, even if you would remove that thing, the resources it created in the host cluster, they would still remain, right? So if you have business critical applications, once they are synchronized to the host cluster, they will just run. There's nothing that can happen to them because they're already there, right? The vCluster is like one layer on top, one abstraction layer. But if you take that away, there's not going to be any more access, but the resources will just remain. So from a stability point of view, like an operational point of view, you're not losing out. You're not introducing something that is not stable enough to operate. And if at the end of the day it's something doesn't work, you can always just remove it and go back to the host cluster and fix it in there. So it's not that you're locked into something. It's just a level of indirection that provides you with easier tools to work with Kubernetes itself.
I guess the big question is Kubernetes ready for your critical business applications? And if that answer is yes, then pretty much, right? Like as long as your Kubernetes install is working in that way.
Yeah.
All right. So are we ready for the second question?
Yeah, hit me.
We move on. Okay. So what production use cases are customers using vCluster for? So this is one of the questions we got to. So a little bit of background. We had two presentations pre-KubeCon at the co-located events. One was with CoreWeave, and then one was with Scikit, I think. Is that the right name? I might be saying it wrong. But the first one like had a lot of people that came up and asked questions because like, oh, CoreWeave's using this in production. Like what are they using it for? And like they just kind of showed quick cluster creation for tenants and stuff like that. But what are some of the production use cases that you've seen that are popular?
Well, it depends. I think the other popular one is from CodeFresh, from the Argo CD guys.
Yeah.
Which basically just say, hey, instead of rewriting our software that we have that works in one Kubernetes cluster, we're just going to put them into vClusters, right? And that's like a super easy way to turn your Kubernetes operator or whatever you have that is technically a single tenant solution and make it multi-tenant immediately, because you're not suddenly confined by everything. And it also makes it much easier to develop your software, because suddenly you don't have to think about repeatedly having multiple tenants, separating data properly and what's not. You can just spin up a new instance of your application that runs in its own cluster. They can't access anything else. You have nice and clean separation, but you don't have to pay for the overhead. Or you technically don't have any overhead. You can have much better bin packing, scheduling, et cetera, et cetera. So when it comes to doing multi-tenancy or running your application multi-tenant wise, that's a great production use case in my opinion. And then you already mentioned CoreWeave. Whenever you want to create a platform, for example, internally, and you want to allow people to spin up a Kubernetes as a service, right? Because you oftentimes have containers as a service and namespaces as a service. You sometimes also want to do Kubernetes as a service. And that's also a great thing that you can use it in production and customers are doing. It's basically to say, hey, we have this one cluster, we take care of that. And then you have self-serve where you just create your own clusters running on top of it. So that's yet another use case. And that's also what our commercial offering is basically about. It's about enabling you to do the self-serve, whereas you can still do everything with vCluster itself.
All right, so we had a question too. So will vCluster save costs on the number of nodes? I see that many vendors, Sysdig, Fairwinds, Ground Cover, Mirantis, all charge based on a number of nodes in operation. How will they see the vCluster as node or Kubernetes cluster? So like, yeah, it's pods, right? So like you will save on the number of nodes, because what you're doing is you're just trying to, like, it's going back to virtualization. Try to put as much stuff as you can on a single node, right? Like you can use a node and have multiple clusters. Here, I'll let Thomas go.
Oh yeah, no, that was great. That was great. So the thing is that within vCluster, you don't necessarily have any nodes. Because it's just there so that when you deploy a scheduler, it sees nodes, can make scheduling decisions. But technically, you don't even need to have access to the physical nodes or know about them. What technically is happening, that all of the workloads that are within this vCluster, and all your deployment stateful sets, whatever you define in there, is going to be put into the host cluster, and it's going to be running in there. So you don't have the issue of nested virtualization where you're running multiple virtual machines that are each built per node, because a virtual machine would be one node. But you can think of it of like going back to like the hypervisor level, or let's call it pseudo hypervisor, or whatever you want to call it. And you can have one big machine and everything just runs on this one machine. So if we think about the fact that you can have multiple clusters with multiple nodes, you have to pay for each node. But if you manage to combine those things into one cluster, you get the benefit of bin packing your workloads much better than before. Let's say your cluster only utilizes 70% or 60% of its resources, because you still want to be able to burst up and down in situations. Now you can save much easier, because if you have 60% unused in 10 clusters, that's basically 6 clusters that are completely unused, right? But if you can consolidate all of those things into one bigger cluster, you don't necessarily need to have those 6 clusters that are idling. You can basically just reduce the compute and the amount of nodes down to a much lower level and achieve a higher percentage utilization on less nodes, which basically helps you avoid fragmentation and other issues that are driving costs up, while not losing any of the benefits, or while not having disadvantages in that sense. And if you have services that are basically billing you on the amount of nodes that you have, that's basically a great cost optimization, because you can now say, instead of having 10 clusters with 5 nodes each, that where 2 nodes are basically idling, I can just have one big cluster with, let's say, 60 nodes, whereas I technically only need 50 nodes, and I'm being billed for that and not for 100. So just by the fact that you can have a better scheduling with less fragmentation, you already start saving on the cost.
And then the enterprise gives you kind of like the idea of oversubscription with being able to put stuff to sleep and scale to 0. Right?
Yes,
Like you can...
and that's another benefit, where if you go for the commercial route, where we have got those sleep mode features, whenever, for example, your vCluster isn't being utilized, because nothing's accessing it, or you're not accessing it via an ingress, it can be automatically turned off after some while. And by turning off, it just does the vCluster sleep, which is also in the open source CLI, and it just puts them to sleep, shuts down all the deployments. And because you don't have the deployments anymore, or the pods that are being managed by the replica sets from the deployment or from the stateful set, you use less resources. If you have something like cluster autoscaler, it is going to scale the cluster back, so you have less nodes in your host cluster, in your physical cluster, and you're going to pay less, because you don't have to pay for the licensing of the services, and you don't have to pay for the compute itself.
Yeah, so it also depends on like how sysdig and stuff setting things up. Like if they're just monitoring your base node, or if you're doing, you know, one per every virtual cluster because you want to do tenants and stuff. Like if you're doing tenant wide stuff or tenant specific stuff where you're installing something to monitor in each vCluster, then that is going to be like, I don't know if it's still not nodes. It's not nodes. It's just cluster amounts. All right, so we have another question, which we actually have a slide that's going to kind of go over that. So I'll mention it now, and then I'll move on to the. Well, I'll mention the question when we get to the slide. Let's go to the next slide. Okay, so like this is one of the questions we got a lot. Like I said, background, CoreWeave did a presentation with Lucas, and they were talking about how they're giving access to GPUs and using vCluster. So they're using vCluster to spin up a tenant to have access to that GPU. And that was one of the big things at KubeCon 2 this year is how do I, because previously, what, you can correct me if I'm wrong, Thomas, it's like it was a 1-to-1 driver for NVIDIA to a graphics card per like container or whatever, right? You couldn't split it up or do like what you're doing with VMs and stuff where you're sharing it. But now there's a driver. I don't know. Does everybody have access to it? Is it generally available, or do you have to get it from NVIDIA still? Like there's a driver that lets you do fractional GPUs. So you can split it up and you can share it, and you can share time on it.
Yeah, if I recall correct, it's probably the device plugin API or something like that,
okay.
Where if you install some kind of daemon set in your cluster, it will be able to report the resources that exist on the physical node, and then the scheduler can start utilizing that for scheduling decisions. And as you just mentioned previously, you were able to specify custom node resources, but you were not able to do fractions of that. So when you just said, I have one GPU, the scheduler could only take in one GPU, because and you also aren't able to burst. If, for example, you had two GPUs on a node, you weren't able to just say, I want to have one because it or 1.5 because it can't do fractions. But yes, now with the device plugin API and being able to report the actual available resources to the API server, that is now possible.
It's just like pass through again, right? Like we're just reusing kind of what you would have done with VMs.
Yes, basically. Basically that, yeah. And I think with the more expensive NVIDIA cards, you can also subdivide one GPU to basically become 4 GPUs, and start utilizing it like that. So you can turn that into a multi-tenant GPU on a hardware level, and now you can basically do this within Kubernetes itself.
That's a big change. It's gonna make it like,
yes,
that's gonna make it great for people that are either running on-prem or they're using like one of these GPU clouds or something like that. Like it's awesome, right? Like,
yeah,
I think even NVIDIA is starting to do their own. Yeah.
Because at the end of the day, if you looked at like GPU pricing, you basically got one massive GPU and you had to pay, I don't know, maybe $5 to $10 an hour. But you maybe only wanted to have a fraction of that because you wanted to run a small interference job, or you wanted to just do some small computation or some small prompting and then just shut it down again. So now you'll be able to have smaller amounts while not having to overpay for basically unused compute.
And so where vCluster Pro, like the enterprise thing comes into it, is they were using it to be able to run like headless, right? Like, so they have a control plane where they're running vCluster. They have these nodes that have GPUs. They don't want to run overhead of vCluster or vCluster pods per vCluster on that node. They just want to have nodes that are accessing the GPU and the resources that are expensive.
Yeah,
like,
it makes a lot of sense, because at the end of the day, if you just take a look at it, if GPUs are extremely scarce right now, and it's like
Yeah.
rare to get new ones. It's very expensive, and if you can squeeze in any kind of workload into some kind of free GPU or into some kind of GPU compute, you're maximizing this scarce resource that exists. Whereas with CPU and memory and what's not, that's like less complicated, but GPU is like really the core that you want to achieve. And so the vCluster Pro feature that they're utilizing, which you already mentioned, the headless and the remote workload clusters, is basically that they can have two host clusters. In the one cluster, you run your vCluster control planes, where you store all of your data, where you give access to your tenants. And then there's a completely separate cluster that can be anywhere you want, that is going to run those actual workloads. And from a engineering point or from a utilization point of view, that makes a lot of sense, because you want to sell your customers GPU time, or you want to maximize the GPU time that is available, and you don't want to have a pod not being scheduled onto a GPU node because there's some kind of vCluster pod or CoreDNS pod running, that blocks the CPU requests from actually executing, even though it's not needed. And if you start scaling that up, you will have more and more compute that is unnecessary, and you suddenly might end up in a situation where you can't use 10 GPU nodes because they are just completely full with non-GPU workloads.
Yeah.
So you want to keep that separate.
You get a bunch
That's
of
also
tenants
great for
asking for
security.
access at the same time. Yeah, 10 people asking, and all of a sudden you've got like all these extra stuff, and like you have to bring up another node, but instead this makes it so you can use the same node.
Oh yeah,
All right, so
and I mean, it's also like great for security if you think about it, because
yeah.
you can have one Kubernetes clusters where you just check for the control planes, for the health of the control planes, and there's like the data, but the actual execution part is somewhere completely different. It can be in a different network zone. It doesn't have to be accessible. It might not even be accessible to people that take care of the control planes. So you suddenly can have those separation of concern, separation of workload data, so that somebody who can, for example, access the control planes doesn't have access to the actual training data that you're doing. So you can have this better separations of concern, if I want to call it like that.
Right, awesome. I'm gonna go on to the next question, but also for people that just joined, like if you joined a little bit later from the beginning, if you have questions, just post them. We'll have a Q&A section at the end, but like if you have questions throughout, like that's fine too. All right, so can I use different versions of K3s K8s from the base cluster on vCluster? So this is a question we got a lot too, is like, can I test on different versions of Kubernetes that are separate from the base cluster? And then on top of that, is there a restriction with how far ahead you can go? Like that was the one question I have. Like, how far ahead can you go from the base cluster to where the base cluster can't figure out how to actually create the resource? Is that a thing?
Well, yes and no.
Okay.
So within vCluster itself, or within the synchro, we have a prober that is looking which APIs are supported and which aren't. So it can, for example, tell you that you cannot use the older ingress resource because it doesn't exist.
Yeah.
So what's going to be happening, or can happen, for example, if resources get deleted or added in newer versions, your older resources might not be able to be synchronized into the host cluster because it doesn't exist. It doesn't exist yet, or it doesn't exist anymore. So you can go apart, but once an API is deprecated, you probably only have got like 3 to 4 versions until it gets completely removed. So that's also what we are basically dealing with. If your host cluster starts getting bigger resource removed, you're not going to be able to synchronize them because they just don't exist. But things like additional fields are completely fine, because those are mostly optional. They have default values, so you can have drift of, let's say, 1 or 2 versions, and it will probably be fine. So yes, you can, for example, try newer versions of Kubernetes. You can try 129, 130 if you're running 127. But if the feature is not supported on the host cluster, it will not be working within the vCluster. If there was, I think the new sidecar container, which you have to define as an init container, if you're running on an older version that doesn't support that syntax, it probably won't work, even though it should work with the version in your vCluster. But if you do it the other way around, that should work perfectly fine.
That's a good way to test too, right? You just run like a way newer version in vCluster, and you're running an older version of Kubernetes. Oh, this works, and it doesn't work. So
Yes.
you need to change a couple of things. And there's now stuff that's moved into networking that was outside of networking now. All right, cool. All right, so you can use different versions. It can't be that different, like as in like huge changes, but like for the most part, if you've been using it in like the last like year, like probably like
Should be fine.
within like the support timeline. Okay. Okay, so this is kind of going to the between multiple vClusters. So does core DNS allow cross-cluster resolution in vCluster Pro? This is going to the enterprise section again. So can you explain the difference between OSS, so open source, versus the Pro version, and like how networking will look different with that? Like, do you need a service mesh for open source to get the same kind of things you can get with core DNS with like a control plane, or okay?
Yeah, I think that also goes hand in hand with the question from the chat, which is about how services communicate with vCluster. So it's probably makes more sense to start there and then go to this feature. So the way that services communicate with each other within the vCluster, or like multiple vClusters and the host clusters, is just plain and simple. Because it's not that you're separated on a networking level, like your vClusters don't run additional CNIs that then get attached to your pods. Everything is synchronized on the host cluster. So think of it like a copy and paste, and you just make sure that no fields are going to be colliding. So if we now start copying those resources from vCluster to host cluster, if we have a pod in the host cluster, it can just communicate with a pod from another namespace. And for a cluster operator, a vCluster is nothing else than just a couple of workloads in a namespace. And if there's a second vCluster, it's yet again just a couple of workloads in a namespace. So if you suddenly want to do communication from one namespace to the other, you can just do that, right? Because it's namespaces. Now with vCluster, it's a bit different because the namespaces and the service names and the deployments and the pods get rewritten. So there's a translation rules that basically say, no, if you have my service default service cluster local, whatever, right, you're not allowed to have that name because it might be collide. If somebody in a different vCluster creates that, it's just going to be the same name and it wouldn't work for non-namespace resource. Anyway, so what effectively happens is we start translating that in the host cluster. And then from any kind of workload within there, if you allow the host DNS option, any of those pods would be able to resolve the IP addresses within the host cluster from those other services in other namespaces.
That's isolated versus not isolated, right? Like when you see it in our docs.
Yes, and then there's also set host cluster fallback DNS, I think, which you would need in this case, because each open source vCluster has its own core DNS deployed. And that has to do with the fact that because we translate the names of the services as well as of the pods, naming wouldn't work anymore if we would deploy it without core DNS, because suddenly it's not my service.default namespace. It would suddenly be my service-x-default-whatever .namespace. So the names wouldn't align and DNS wouldn't work. So each vCluster gets its own core DNS that is then resolving those names to the names within the vCluster, or that you're as an end user are expecting to interact with. So when you enable the host DNS fallback, you basically just say, all right, if you cannot find the name in here, just go back to the host cluster DNS and try to find it there. And most of the time when you use the actual synchronized names, it will just fall back to host and route you to that other service if you're not isolated or if you have network policies in place that allow you to do that. And the same applies for workloads running on the host cluster that want to connect to something in a vCluster. Because again, if it's put into a namespace, it just workloads in a namespace. If you have a Prometheus that is in your cluster and you allow it to just scrape all those resources in different namespaces, it will just connect to it, right? There's like no special things. It's not connecting to the other API services. It just sees that there's a pod that it's supposed to scrape. So that's what basically happens. Now, the cross-cluster DNS resolution is an opinionated implementation within our commercial offering. So what basically happens is in the pro versions, we just say, all right, maybe deploying a core DNS pod right next to a vCluster can be a bit cumbersome or heavy on operations. So in an opinionated manner, we just said, all right, let's pull the source code from core DNS and put it into the syncer. And once that happened, we basically say, all right, the syncer is now both the component that is copy pasting your resources as well as doing the DNS resolution. So at the end of the day, you basically just say, all right, that's great. I just have it in one place. And now you want to have multiple vClusters communicate. Now, as I just mentioned, usually you would have to do something like set host DNS fallback, but that also has its drawbacks. Drawbacks in the sense of isolation, because once you can get to the host cluster's DNS, you can basically say, all right, so what other services exist? And so suddenly you can start, let's say, exfiltrating or gathering information on what else is running within the cluster, which you might not necessarily want to share with tenants that you have, right? If you're an organization and everybody trusts each other, that's perfectly fine, right? But if you're in a situation where you do not trust each other, you cannot really say to fall back to hosts, because then you just give away information that you shouldn't have, and you have a data breach or any kind of other security issue. So what exists here is that we basically say, all right, if we have two services in two vClusters, we write a opinionated plugin for core DNS that is part of vCluster Pro that is also integrated into the syncer component. And we just say, great, so give me a mapping of what I'm supposed to resolve and how. And then what basically happens is that the vCluster resolves it and routes it to that service in a different namespace, in a different vCluster, and it just tells you the IP address where you're supposed to connect. But it doesn't share more information with you about what else is running, because it's a pre-configured thing.
Awesome. All right, let's move on to the next one. So we've already gone 30 minutes. I think we're like right around halfway or a little bit over halfway of the for the questions.
Oh, that's
okay,
good.
5 more slides. Okay. So can I use a different version of CRDs from the base cluster on vCluster? So this is going into, we have a different API running within vCluster. Can I now install different versions of CRDs in there?
Oh yeah.
And then what's the restriction? Like, is there a restriction of like versioning there too, right? Like Cert Manager, if I'm using some like old version to Cert Manager, like it's not really going to work the same way with annotations and ingress like it does now, right? So I have to kind of think about that too.
Oh yeah, so that's great. So in here we have multiple operational models. Because as I said, the syncer is a component that can basically copy paste resources from your vCluster to your host cluster. And with the, I think, generic syncer or generic sync config, you can basically say copy whatever CRD I tell you from whatever API group, version, kind into the host cluster and apply specific rules when rewriting it. So that works, but this has the drawback that you have a specific version running within your host cluster, or a specific CRD version deployed in your host cluster, and you cannot experiment anymore, because you cannot use a newer CRD version that has a breaking change, because it would break for everyone. But what you can do with vCluster instead is basically just keep everything confined into your own API server, because vCluster basically just spins up an API server that you connect to, which is a kube API server, and it deals with the data in the background. So when you now deploy a CRD, you're technically only deploying it into this API server that is running within a pod, within a container. And it doesn't interfere with anyone else running, right? It doesn't interfere with somebody who is on a different vCluster, and it also doesn't interfere with the host cluster itself, because the resources only stay within this API server. And also when you start deploying custom resources, those things just stay in this API server. Now, when we, for example, create custom operators, I just remember that I used to use an open source MongoDB operator, and from version 0.5 to 0.6 or something like that, there was a big breaking change where we basically had to replace the custom resource definitions, because they started to rename field or shuffle them around. And that was a breaking change. But what you could do with vCluster is to just say, all right, fine, I don't need to rip this out for all the tenants at once where something might break. I can just do it on a per vCluster level. I can just do it over and over, and I don't interfere with them, because again, the CRDs just stay in this API server and they never leave it. And the pods that are the result of it. So when a operator says, all right, I see that there is a CRD and I'm supposed to create a deployment and a service, it will create the deployment at the service. And then the pods that are results of it will be copy pasted into the host cluster running it. And that's basically how you can run different CRD versions without interfering with anyone. And the same applies to ingresses and to other resources, because we can also say you don't necessarily need to use the host cluster's ingress resource definition, right? Maybe you want to use the gateway API. And the gateway API is basically a CRD that you install into your cluster that is then being utilized by your ingress controllers. Maybe you do not want to use the same ingress controller as your host cluster does. Maybe you want to use, I think, the UDP port or something else that is offered within Gateway API, but might not be installed in your host cluster. So you can install the CRDs that you need in your vCluster. You can run the ingress controller that supports the Gateway API version that you expect or that your application needs. and it won't interfere with anyone else. So you basically get around this issue of CRD versioning by just not dealing with it.
Yeah. I'll say for everyone too, like if you want to re-listen to any of these answers, like this is going to be on YouTube too. So this is getting recorded. So you can go to our YouTube channel and you'll be able to view this. Let's go to the next one. We kind of talked about how headless mode works in vCluster Pro. I think as we're getting shorter on time, I can go to the next one. Mm-hmm. Basically, you install stuff into a cluster and then you have access to other clusters you can add into it. All right, let's go to here is a question we got. What are the limitations of vCluster compared to a real Kubernetes cluster? So I'll go to Tomas. Like,
oh god.
It is a real Kubernetes cluster, right? So that's
yes.
why it's like in quotes and stuff like that.
Yeah, I mean, it like really depends. Because a lot of people think that it might be some kind of virtualization, but technically there is none. If you spin up a cluster in GKE, EKS, whatever, you don't really know how the control plane works, right? You only know that you have some nodes in your VPC that connect to it, and that thing is completely abstracted away. Nobody knows if, or it's not necessarily public knowledge or anywhere written down how those services work, right? They might not be spinning out cloud virtual machines anymore. They might be spinning up control plane pods in another Kubernetes cluster or some kind of other orchestrator, right? So in that sense, a vCluster is as much a real Kubernetes cluster as the managed services that you get with any cloud provider. Because again, all that they do is just spin up an API server and some database in the background that deals with it. And that's exactly the same what vCluster is, because vCluster technically is just an API server and some kind of data store that keeps your data. And then there's some smart logic that basically synchronizes it into a host cluster. But technically, you could also just say, all right, I don't want to synchronize anything. I just want to run K3s in a container and connect nodes to it. And that would also work and would also be a real Kubernetes cluster, even though you're not running the Kube API server on a bare metal machine or on a virtual machine natively.
Sounds good. All right, let's go to the next one. I know we've given such long answers on the previous ones. I just want to get through the last ones, especially so if we have like QA or anything like that too, we can go through it. All right, so what are some of the use cases for using isolated control planes for vCluster Pro? So we talked about like
security,
GPUs,
privacy.
And kind of touched on that earlier.
Yeah.
Kind of just reducing workloads on the cluster, or reducing workloads on the nodes that need to be able to run workloads that matter is a big thing basically. Too, and not getting like plus one pod for every vCluster you're running in case you have a lot of tenants. All right, so actually we can go to the QA then now. So we kind of made it through. If anyone has any questions, we thank you for joining. We got more information right after this, but if you have any questions, now's the time to ask. If you've been holding off, or maybe we didn't touch on something that you're interested in, I'll talk about like where the links are and stuff for you to check out vCluster, how to contribute, and then how to get questions answered. But I guess post some questions in there if you have any questions. We'll go on a little bit more for a minute or two about different use cases that we can think of. But like I said, ask any questions that you may want to ask. Or if you're just new to vCluster, maybe you have like a question for like quick start, like how do I install this? What can I install this on? Like, can I use this on EKS? I don't know. All right, so let's think other use cases, right? Like what use cases did we see at KubeCon? So I saw a good amount of questions, which is interesting. So I'd say KubeCon Detroit, I saw a lot of contractors, government contractors and stuff like that asking questions. And like the big question from everyone was FedRAMP, right? But this time in Chicago, a lot more of the questions seem to come from like academia and like, how do I get access to GPUs? Can I use this for like supercomputer type stuff? I think they're using Slurm or something different than that. But we had a lot of questions about like, how does this work? How can I use this in academia? How can I empower people to use Jupyter notebooks? Like that's the big, like one of the most common use cases I keep seeing is how do I use Kubernetes to empower my data scientists to use Jupyter notebooks? And maybe that's just from like seeing so many people from academia kind of ask a question, but like I think that's another one is like some people are using Kubeflow in production. Some people are just giving people a vCluster with a Jupyter notebook stood up inside of it. I don't know. What do you think are some other good use cases, Tomas? I would say that's what I saw a lot at this KubeCon, which is different than what I've seen previously.
Yeah, I think we're seeing the shift more towards like creating platforms and basically being your own cloud provider. Well, let's say being more cloud provider agnostic or aiming to be it. And a great vCluster use case is to spin up an easy Kubernetes as a service, or just get to the point where you have Kubernetes as a service without having the financial disadvantages of running 100 Kubernetes clusters, or just spinning up a Kubernetes cluster quick and dirty, do some PR checks, and then just remove it again. Because if we look at bigger cloud providers, it can take up to 10, 15, 20 minutes to spin something up. where the test only takes 30 seconds. So you waste a lot of time and you can't go on with your PR, with your test or check or whatever, because it just takes a long time. And with vClusters and vCluster Pro and other solutions, it's just oh yeah, there's an API server. Oh yeah, that works. Okay, I can just move on and I don't need to care about that. And then that's something where I think we're heading to, sort of comparable to like databases. If we like think about it 10, 20 years ago, there were like database administrators, right? And like those people who really knew databases, and you had one big database. Well, technically, it wasn't a database; it was a database management system. And I think that's something we're also heading with Kubernetes, because Kubernetes is the database, right? Where you store your data, which is running your workloads, etc. But it has the same limitations as a database. And with vCluster, we basically bring the missing management system into the game, because suddenly you've got your databases or your Kubernetes APIs, and you write your management system around them, and then we just deal with running your actual workloads.
All right, cool. We got some questions. All right, so how much memory and CPU is occupied by the vCluster? How will the vertical auto pod scaler or horizontal pod auto scaler work? Is vCluster compatible with Carpenter and Keda?
Yeah. So vCluster itself, depending on which distribution you're going to be using, because we have the vanilla Kubernetes one, we have K3s, we have K0s, and the EKS Anywhere distro. Those are going to have different resource requirements. If we go for the K3s one, K3s is comically small. Because in our case, we do not need the integrated container runtime. We don't need to have the scheduler. We don't need to have any of the other controllers that usually run with a K3s installation, because all that we need is API server, Kine for the etcd shim, and I think the controller manager. And those are like three components that run in the K3s vCluster, and the vCluster syncer. And like that's about it. So from a resource perspective, we're probably not even going to be hitting a core or 100 megabytes of memory on a vCluster instance, on a vCluster pod that's running. It's much, much, much smaller, because effectively that thing isn't doing anything apart from holding your state and reconciling. So how it will work with the vertical autoscaler or the HPA, or even with cluster autoscalers like Carpenter, that I'm sort of combining those both things. It just works the same as if you would suddenly deploy 10 pods in a namespace, and they wouldn't be able to schedule. So cluster autoscaler or Carpenter or Keda would just spin up your deployment. There would be more pods. They would see that they need to add more resources. They would add more resources. Now, once you scale down your deployment again, it would be scaled down in the host cluster, and your Carpenter or cluster autoscaler running in your host cluster would be like, oh yeah, this node isn't needed anymore. I can just free it up. I can just give it back. So that works the same in here. And now, because of the bin packing effect, where if you have 10 clusters or 10 vClusters crammed into one, you would use less resources. And if you put a vCluster to sleep, those unused resources would be freed anyway.
All right, so we have the next one. What is the footprint of a typical vCluster deployment? I hear Kube API, Core DNS, what else? So I guess other CRDs and stuff you installed too.
Oh yeah. No, that's exactly it. So when you have a vCluster, and in newer versions we even optimize a bit further. You only have one container that is the vCluster, and in this container we're going to be running the syncer, the Kube API server, or the K3s distributions, for example, and potentially some embedded etcd if you chose to do that. But all of those things run in one container. And once the syncer exists, it's going to deploy one core DNS pod, which also has very low footprint because it just does DNS for this one vCluster. And that's it. There's nothing else, no more. It's just two tiny resources that are going to be created in your cluster, and that's about it. And everything else is just going to be reconciled, put into the host cluster. Any status information from the host cluster is going to be put into the vCluster, and that's it. No more magic.
All right, so the next one. We're using Rancher for RBAC. Is it a good idea to connect vClusters to Rancher when we don't want to give a customer full access?
Oh, that's a great point. I don't know if I'm supposed to spoil it, but yes, you can do that. You can do the Rancher integration yourself, or you can use the vCluster Pro Rancher integration. Yeah, that's like in the works or going to be published soon, which creates a Rancher plugin for you that deals with all of those things. And it synchronizes the permissions that you have in Rancher into the other one and back. So that works.
All right,
But
so
it
like,
works both ways because anything that we do in, for example, the commercial offering is built upon open source, right? That there's no secret API, there's nothing hidden. You can still do that, and yes, you can manage it however you think makes the most sense for your use case. Because at the end of the day, vCluster is supposed to be this unopinionated thing that you can adapt how you want or how you need or what your opinions are. And if you want to keep your RBAC and Rancher and keep it in Rancher, use the tools that are already known in your organization and integrate it the best way that works for you.
here's a question too: is can I use more than one architecture with vCluster? So AMD 64 versus ARM. Like, can I use
Yes.
both? I
Yes.
haven't even looked at the
So
images. I imagine we do.
yes, so that's basically how it works. Because vClusters are just workloads in your host cluster, it just entirely depends on your host cluster and on the images that you're building. Now, if you're building multi-arch images, then wherever you put those workloads in or whatever nodes you put them in, they will just download the image for that corresponding CPU architecture and they will just work. Because at the end of the day, the vCluster image is built for, let me check, because I built those scripts with Go
The basic
releaser.
answer, yeah, yes, right. Like, you just check out what image and stuff, and then
Yeah, so we support with vCluster both the x86 as well as ARM 64 and ARM v6. So you should probably be able to run it wherever you want or need.
all right, cool. We got one more. I would like to deploy vCluster on Oracle Cloud Infrastructure. Has anyone deployed it on that yet? I haven't, but maybe we have people that have. Right? I mean, as long as it's running Kubernetes, it should be okay, right? Like, there might be
Yeah.
some things we can work through. Like, if you deploy it, if you have any issues or anything like that, open an issue for us. I don't know if are we testing on Oracle Cloud Infrastructure, or I don't know.
I haven't worked with Oracle Cloud yet, but from a higher level point, you shouldn't be running into issues unless you're trying to use some cloud specific integrations, which might need some readjustment or additional configurations. But from a pure deployment point of view, it should just be a standard deployment that you're running in your cluster.
All right, so we have a question basically: are we thinking about incubating with the CNCF? I don't know if we're doing that yet. Maybe in the future, something like that. One of our projects is Depspace, but I think we're trying to make sure that we keep vCluster kind of opinionated in the way that we think it should be built right now. Maybe future, I don't know.
Yeah, it's more of a thing that we did it with Depspace, and it took a lot of time. And we don't want to rush things right now because there's still things to do and still things to build. And a donation process isn't something that you can just easily do. It takes time, it takes effort, and that's something that we will eventually look for, but it's not a massive priority right now. And there's nothing blocking anyone from adopting vCluster right now. It's Apache 2, and that doesn't change.
Yep. Are there any major non-Loft contributions already? You look at the contributors. I don't know how large it is. There are external contributors in addition to Loft contributors.
Oh yeah,
All right,
absolutely.
so
If there's something that doesn't work for you and you implement a fix, please contribute it, right? Like we're super happy when there are people finding issues and fixing it themselves. I think that's like the entire point of open source, and we're very grateful for that.
I'll say, as we go on with these office hours and get more contributors who are interested in interacting like on a monthly basis too, we can probably have someone come in and like present something that they want to contribute and see what people think. Like, that's usually, office hours kind of is that usually. Right now we're just kind of trying to inform people on vCluster. All right, so is it good practice to run vCluster in non-HA mode in production? It depends on what you want. If you want ephemeral, yeah, right. Like, if you're doing ephemeral stuff, it doesn't really matter. If you're trying to keep production stuff running in vCluster, like we have HA modes that you can actually configure. Let me go to the next thing too, which are actually on our docs. I'll let Tomas answer that one. I think we'll have to stop QA there, and then like I'll do our outro just because we're kind of getting close to time. But
sure. So I'll just spin about that thing. Yes, you can run it in non-HA, but you need to have a database outside that is somehow keeping your data. And in that case, you can just run it on HA, have the data somewhere else, and it's perfectly fine. If you want to run production, be super stable and whatever, and you do not want to use an external data store, you probably should run it in HA. Speedrun.
All right. So our outro: how to get involved or ask questions. So here's our GitHub. Like I said, this is recorded. You'll be able to see it. I'll put these links on our YouTube link too, or YouTube video. You can join Slack and ask questions in vCluster, the channel. Probably have Tomas or myself answer it, or someone else internal as well. Read the docs, vcluster.com/docs. We've got our pro stuff there too, so you can actually see what the difference is between vCluster, OSS, and Pro. And then you can follow us on social to get updates. So there's our LinkedIn, our Twitter, and our YouTube. And I'll go ahead and move on and say, I'll leave this on for another second. All right, now move on. Thank you so much for joining us for our second office hours for vCluster. If you enjoyed it, let us know. Hopefully we'll be back in the new year in January and we'll do this again. And if you have questions, just think about them and then bring the questions. Or if you have questions, ask them in Slack, and we'll be happy to answer them. But thank you so much for everybody for joining and coming in and hanging out with us. Thank you so much, Tomas.
Thank you for hosting it, and Ashish, thank you very much for setting it up.
Yes, thank you, Ashish. And thanks for the questions. Thanks for the audit. Like, you make it so much easier with all these questions. We probably could go on like another hour, but I know it's late for some of our panelists too. We're all over the place. All right. Thank you so much, Ashish. You can